Hi, welcome back. So we're going to take a look at another example of Euler's method. Again, this is just an approximation technique and it's using the tangent lines, which we're experts at by now. So we're given the following differential equation, x minus y, and they give us the initial condition. We want to approximate the value at x equals 3.2 using Euler's method of two equal steps. Remember what this is telling me. Once I see Euler's, I'm thinking tangent line, but not once, but twice. So we have to break this down into steps. So I'm going to go ahead and do that. All right, so if I'm starting at 3, I want to end at 3.2. I have to go in two steps. Step 1 and step 2. So the first step has to take us to the point halfway between 3 and 3.2, and that's 3.1. I do encourage you to do this. It does help a lot with the problem. If you notice, we did it on the first example, right? There was step 1, and here was our step 2. So it does help to give you an idea about where you're at in the problem. So for step 1, well, again, we're going to use a tangent line, so we need a point. Now the first point is the one that they initially give you, 3, 1. Next, we need the slope. Well, to get the slope, we use our derivative. And that's just going to be, in this case, 3 minus 1, which is 2. So my tangent line will be y minus 1 equals 2 x minus 3. Now, my first step, remember, we're not going to go all the way to 3.2. We're going to go halfway to 3.1. So we're going to let x equal 3.1 here. And if we do this, y minus 1 equals 2, 3.1 minus 3. And we get y minus 1 equals 2, and you should know that that's just 0.1. So we would get y is equal to 1.2. So that's step 1. Step 2 is another tangent line, except for now we have our new point. At 3.1, we are at 1.2, and there's my new point. To get the slope, my rule says to take that 3.1 x minus y minus 1.2, and that's going to equal 1.9 right there. Writing your tangent line, we would get y minus 1.2 equals 1.9 x minus 3.1. And now I can go the rest of the way. Now I'm going to let x equal what I want. That's that 3.2. We will get y minus 1.2 equals 1.9, 3.2 minus 3.1, and I could just simplify this. 1.9, and this again becomes, what's that, 0.1? So, what's that, y minus 1.2 equals 0.19, and we get y equals 1.39, and that would be our approximate. And if you notice, our slope here is actually decreasing. Our slope goes from 2 to 1.9. Therefore, we know that the derivative is decreasing. What does that tell me about the concavity? Well, if the slope is decreasing, that tells us we are concave down. Therefore, the function is concave down. And in terms of our approximation, well, this would be an overestimate. Remember, concave down, we have an overestimate. Therefore, this is an overestimate. Right there. Now, this one we cannot solve for the actual value yet. We need more like multivariable for something like this. This is a really tough one to solve. All right, so let's take a look at our last example, and then we're done. All right, they say assume that the values of f and the derivative are given in the table. Use Euler's method of two equal steps to approximate the value. So once again, we are looking at tangent line, not once, but twice. Sometimes we've seen that as 3 equal steps, so be careful there. All right, so let's do so again, I'm looking for the value this time at 2.6, but notice they give me the value at 3. Be very careful, direction is important. 3's over here. Every year I have to tell students 3 is to the right of 2.6. So this time my steps go backwards, so be careful. Step 1, step 2. Well, so what's in between 3 and 2.6? then you should probably get it 2.8. So the first thing we have to start with, our initial condition. So a point, so for step 1, we need a point, and they give us a point 3. Be careful, that's the derivative, 3, 2. The slope, that's that point 4. They tell me that. That's f right there. So my tangent line, y minus 2 equals 0.4, x minus 3. Now remember, we can't go directly to 2.6. We have to stop off at 2.8. So I'm going to plug in 2.8 right now. X equals 2.8. And we get y minus 2 equals 0.4. 2.8 minus 3. And that becomes y minus 2. And if you're good, that's just negative 0.2. So what's that become? Let's go 0.4 times negative 0.2, which is negative 0.08. Adding 2, we get y equals 1.92 right there. So there is my next value right here. So I'm going to go ahead and plug that in. 1.92. There's my value. So for step 2 now, starting at x equals 2.8, where my value was 1.92, find the slope. Now the slope we don't do too much because they give me the slope is that it's 0.7. So my tangent line, y minus 1.92 equals 0.7, x minus 2.8. And now I can plug in my 2.6. Let x equal 2.6. So let's see here. Plugging in, y minus 1.92 equals 0.7, 2.6 minus 2.8. So we would get y minus 1.92 equals 0.7. Again, times negative 0.2. Notice this should always be the same, by the way, that difference. And that's just, what's that, negative 0.14, something like that. And when you add, we're going to get y equals 1.78. And there's my approximate value, 1.78. Now, let's see if this is an increasing or decreasing function. Let's see if the concavity is increasing or decreasing. What's happened to the, let's talk about the concavity, excuse me. So let's look at the slope. Now, be very careful. Even though we're going backwards this way, to determine concavity, we have to go the normal way. Here, we're going from 0.4 to 0.7, from 0.7 to 0.9. So what's happening? Whoops, sorry, we're going the other way. There we go. Sorry, 2.6 was over here. So we are decreasing, excuse me. So the slope for 2.6 is 0.9 to 0.7 to 0.4. So the slope here is decreasing over time. So we can say f prime of x, the slope is decreasing. Therefore, f of x is concave down. Well, what does that tell us about our approximation? Well, concave down looks like this. So therefore, you can say our approximation, should be the best way, is an overestimate. All right. I sure hope you enjoyed those videos. I enjoyed making them, mistakes and all. Again, don't worry about making mistakes. We all do. Just be willing to fix them like we did, okay? All right, I'll see you soon. Bye-bye.